Hey everyone, welcome back to our daily food challenge series. So today is day 101 and today we are going to solve LeetCode problem 24, swap nodes in pair. Okay, so this is a medium level problem. So let's see the problem set first. So we have given a linked list, swap every two adjacent nodes and return its said. You must solve the problem without modifying the values in the list nodes. Okay, only nodes themselves may be changed. Okay, so we have given the single linked list and we have to like basically swap the values of each pairs, right? So here in the first example we can see we have linked list nodes 1 2 3 4. So we will swap first two pairs, so one will become at the place of 2 and 2 will become at the place of 1 and vice versa, like 3 will becomes like exchange with the place of 4 and 4 will becomes at the place of 3, right? So in the picture image you can see, right, this is how it happened and the final output will be 2143, right? Similarly in example 2 we have empty simply, so there is no nodes to swap, right, their positions, so we can return empty as well. If we have single value, we don't have any pairs, then we can't like swap the values, right? So we will return as it is even in that case. In case of we don't have much pairs, let's say in the example 4 we can say only one pair we have, so we have swapped that values, but the next one is not creating any pair with any other value, right? So we are just remaining as it is. Okay, so in the constraint part we have given the number of nodes in the list is in the range of 0 to 100. Okay, and node value can be ranged from 0 to 100 as well. Fine. So to solving this problem, like we can go straight forward with the simple approach, like we'll iterate, we'll find if there is any pair, we'll just swap the values of that node, right? We're not going to modify, we are just going to swap the values of that, right? So for doing that, let's come to the coding part. So we have val and next, like as it is same definition of the linked list. So what we'll do, first base case we'll see if our given head is equals to null. That means like we don't have any pairs to do, right? So what we'll do, we'll simple return head itself here. Okay, now we are going to create one temp node. Okay, so temp, it's a list node equals to temp equals to, which is pointing to head. Okay, and now what we'll have to check here is we basically have to iterate over, right? So two things we will going to check: the existing of the pairs, right, that we basically have to swap. So here we will check if temp is not equals to null and temp dot next. So basically we want current value and the next value as well, so both should be present in order to do the swap part, right? So not equals to null. If this is so, that means we have at least the pair at that time. So what we'll do, we'll just use a third variable, temp variable we can say, in order to store the current value, and we'll swap it. Normal swap logic I'm going to use. So let's say int equal to, so values int here only, right? So int val equals to, we can say temp dot val, whatever value of the current node, right? And now we will do temp dot next dot val will be equal to, sorry, temp dot um, temp dot next val will, I'm going to store the temp dot next dot val, sorry, my bad. So basically we have to just store the next value, next node value in our temp node, right? And now in this operation we are going to just update the value of whatever we have in the temp dot val, right? Now in the third one we're just going to swap, so whatever temp value we have currently, we are going to map it with val that we have stored here, so that is other than just next value of node value, we are going to mark it here. And now we are just iterate our temp equals to temp dot next dot next, because we have to do it the pairwise. So as we have already covered these two pairs, right, we are just going to iterate the next pair, right? And once that all is done, we are just going out and we'll return head. Okay, hope this is clear, and this is a straightforward solution. Let me submit and see. Hope it will work. Yeah, so as expected, all like our whole test cases we are passed and getting spit output. Let's submit and see complete test case scenarios as well. Okay, cool. So we have all passed all 55 test cases and beats 100%. So our solution is anyhow like optimal in comparison with the other solutions that is submitted, right? So yeah, if we talk about the time complexity here, so we are going to visit each and every element in order to find the value and do the swap. Okay, so it is time big of n, and a space complexity we are using just one fixed size. So anyhow, a space complexity will be big of one here. Okay, uh, you know, if any other approach other than like this temp variable, you can just comment it down. Okay, because there are multiple solutions for this, for swapping the nodes and swapping the values, right? We can do anyways. So that's all for today. Let's see you next video. Bye.